In this video we're going to look at how to solve simple trigonometric equations. So this first one, we're asked to find where sine theta is equal to 0.8, and we're given an interval, and the reason we need to be given an interval is because there's going to be an infinite number of solutions to this, and we're only restricted to the ones that lie within the first full revolution, so between 0 and 360 degrees. So I'm going to obtain my first value by doing arc sine of 0.8, and I can do that on my calculator. So just need to make sure that I've got my calculator in degrees mode, and then I can do arc sine of 0.8, and I get here 59.0 if I use it to three significant figures. So there's one solution, but am I going to find any more? Well, what I'm going to do here is I'm going to do an angle diagram. And I'm going to mark on my letters that tell me which ratios are positive in which quadrants. And I'm going to mark on this 59-degree angle. So this 59-degree angle is going to be over here somewhere. And this is where sine theta was positive. So which other quadrant is sine theta positive? Well, it's this quadrant over here, which means that there's a 59-degree angle here as well. Okay, because we're always looking at the angle it makes with the x-axis even. So if this angle is 59 and this angle is 59, well, what's this value over here? Well, that's a half a revolution, so that's 180. So this solution is 59.0 degrees before 180. So my second solution is 180 subtract 59.0. Now when I do this on my calculator, I'm going to use the answer function because I want to keep this accurate. Quite often it could be useful to store these values in your calculator using the memory function, because often you're going to find even more than two solutions, and we don't want to lose accuracy at any point. So I get here 120.96, which if I do it to three significant figures is 121 degrees. So my solutions for theta here are 59.0 and 121. And I can check here with my solution 0 to 360. I've got two solutions here. There are no solutions in this quadrant because sine is negative here. There are no solutions in this quadrant because sine is negative. And by the time we get back to this quadrant again, we've exceeded 360. So we've gone outside of the range of this interval. Second question, we've got the same sort of situation, but we've got a quadratic here that it's already factorised, so that makes life a bit easier. So either from the first bracket tan theta is equal to 2, or from the second bracket cosine theta is equal to -6. Now we should be familiar that the cosine function just goes between 1 and -1, so -6 is not going to give us any solutions. And if we were to attempt to do that on our calculator, it's going to come up with an error as well. Now in this case, we're giving an interval in terms of pi, so we're dealing in radians, so I'm going to just change my calculator into radians mode. And then I'm going to do arctan of 2. So arctan of 2 gives me 1.11 radians if I do this to the nearest to three significant figures even. Right, so I'm going to do my diagram again. So 1.11, well, where's that? Well, this is pi over here, this is 0, this is pi by 2. So where's 1.11? Well, you might not be as familiar with recognising immediately which quadrant it is in as you would be with degrees. So if we want to, just find a numerical value of pi by 2, which is going to be, what, roughly 1.55. So this is definitely in the first quadrant, so that's over here somewhere. Okay, and we're dealing with tan, so where else is tan positive? Well, that's over here. So we've got an angle 1.11 here. So how are we then going to find our solutions? Well, let's have a look. Our first solution, well, we need to go from negative pi all the way around to 2 pi. So if we start here at negative pi and go forwards to 0 and then all the way around to 2 pi. So our first solution is 1.11 after negative pi. So we've got negative pi plus 1.11. Our next solution is here, which is 1.11 after 0, so that's just 1.11. Our next solution, well, there's pi, so this is pi plus 1.11. And then we round to 2 pi, and so we've got no more solutions because we've reached the end of our interval. So what I'm going to do is, because I need to use this value twice, because I need to use it for both of these values, rather than lose accuracy, I'm going to store it. So I'm going to do shift store A. So that's now stored in memory A. So now I can do negative pi plus A, which is negative 2.03. 1.11 is just a numerical answer, and then we've got pi plus what's in memory A, and that gives me 4.25. And now I have all my solutions within the interval.